When we look into the night sky, we're not just looking outward, we're looking backward. Every photon that reaches your eyes tonight began its journey before there were humans, planets, or even galaxies as we know them. But recently, a golden mirror in the cold silence of space did something no eye had ever done before. The James Webb Space Telescope looked into the beginning of time itself, and what it saw shouldn't exist. Picture yourself floating beside it. The Earth is a distant marble, the sun a soft lamp glowing behind a golden sail. Around you there is only silence, perfect, infinite, comforting. The telescope faces away from everything familiar, toward a darkness so deep it feels alive. Within that darkness, the faintest ripples of ancient light begin to appear, carrying stories from when the universe was young enough to still remember being born. The James Webb was built to see what no telescope before it could, to pierce the fog of the early cosmos, to witness the first galaxies forming from chaos. Scientists expected to see small, messy structures, cosmic toddlers just learning to glow. Instead, they found giants, galaxies already mature, massive, organized, far too soon. The data whispered something impossible, that the universe grew up faster than our theories ever allowed. If quiet wonder and cosmic curiosity bring you peace, a gentle like or soft tap on subscribe helps others drift here too. Together, we create a constellation of listeners, small lights scattered across the dark, united by curiosity. So settle in, breathe slowly. Tonight, we'll drift through those golden mirrors, across the veil of time, and into the moment when light itself first learned to shine. What did Webb truly see in that ancient dawn? And why has it made scientists question the story of everything we thought we knew? To see the beginning of time, you must first leave the world behind. The James Webb Space Telescope orbits far beyond the Moon in a gravitational pocket known as L2, a point of perfect balance where the pull of the Earth and the Sun cancel each other out. There, 1,000,000 miles from home, it floats in constant twilight, always facing outward, away from the light, toward eternity. Its mirrors are gold not for beauty, but for function. Gold reflects infrared light better than anything else. Each of the 18 hexagonal panels was polished thinner than a human hair, designed to catch the faint warmth of ancient galaxies, whose light has stretched for 13 billion years. When Webb unfolds, it doesn't open its eyes, it opens time. The telescope sees not the brightness of stars, but their echoes. Infrared light reveals what ordinary eyes cannot, the faint glow of the first galaxies still rising from cosmic fog. Every observation Webb makes is a message from the past, carried across the expanding universe, finally arriving at our doorstep. To understand why Webb is so extraordinary, imagine what it means to look back in time. Light moves fast, 300,000 kilometers per second, but space is vast beyond comprehension. The light Webb captures tonight may have begun its journey before Earth existed. Each pixel of its images is a fossil of creation, a silent photograph of something that may no longer exist. It is a strange paradox. The farther we look, the younger the universe becomes. Webb doesn't just photograph galaxies, it resurrects them. It turns silence into memory. Where Hubble saw a few faint sparks, Webb reveals hundreds, even thousands. Each one a city of suns burning before there were atoms in our veins. This ability is not magic, but patience. Webb's sensors are tuned to the infrared spectrum, wavelengths stretched by the universe's expansion. As space grows, light itself is pulled apart, turning visible glow into heat. To see that ancient warmth, the telescope must be colder than the void around it, shielded from the sun by a multi-layered sail thinner than paper. That sun shield, the size of a tennis court, blocks 99.99% of all heat. Behind it, The telescope operates at just 40 Kelvin, colder than Pluto, quieter than a whisper. In that silence, the faint warmth of a galaxy billions of light years away becomes a signal. The universe is faint, but it's never mute. Building such precision required decades of faith. Thousands of scientists from NASA, ESA, and CSA worked across continents, facing delays, doubts, and technical nightmares. Every screw, every wire, every gold panel had to survive the cold vacuum of space. When the telescope finally launched on Christmas Day 2021, it was more than engineering. It was hope made metal. The world held its breath as it unfolded. For 2 weeks, one by one, its mirrors and shield opened like petals in zero gravity. Any failure would have doomed the mission forever. But the universe, it seemed, wanted to be seen. Each command succeeded, each hinge obeyed. Humanity had just built a machine that could look back to the dawn of everything. When the first light reached its sensors, it wasn't merely data, it was revelation. The image known as the Deep Field showed thousands of galaxies crowded into a patch of sky smaller than a grain of sand, held at arm's length. Each speck was an entire cosmos, filled with billions of suns and perhaps uncountable worlds. Scientists stared in silence. Some cried. Decades of theory dissolved into awe. For the first time, we could see the universe not as it is, but as it was, chaotic, glowing, alive. The Big Bang was no longer abstraction, it was visible history. But soon something strange emerged. Among those ancient galaxies were shapes that shouldn't be there. Spirals, disks, clusters too massive, too organized, too soon. The universe's first generation of stars was supposed to be raw and messy, not elegant and mature. Webb had shattered our timeline. The implications rippled across cosmology. Had our models of galaxy formation been wrong? Were dark matter and gravity behaving differently than we thought? Or had the telescope, in its perfection, revealed something deeper, a flaw not in physics, but in our understanding of beginnings? Some scientists suggested that perhaps our measurements of cosmic distance were skewed. Others wondered if early stars formed faster than expected, ignited by unknown forces. But for many, the revelation felt poetic. The universe had grown up faster than our minds could imagine. Time, perhaps, was more flexible than our equations allowed. And yet the beauty of science lies in its humility. The discovery didn't end the story, it began a new one. The Webb telescope had not contradicted the universe. It had reminded us that creation is still unfolding. Every answer births new questions. Every image is the start of another mystery. If you've ever stared at the night sky and felt small, know this. The telescope that sees time is made of the same atoms that form you. The gold on its mirrors, the silicon in its sensors, the iron in its frame, all were born in stars long gone. When Webb looks outward, it's really the universe looking back at itself. In that reflection lies something tender, proof that curiosity is cosmic. We were made to wonder. The same force that drives galaxies to spin drives us to ask why. Webb is not just a telescope, it's a mirror held up to existence, reminding us that even silence has stories to tell. And as we drift with it tonight, suspended between what we know and what we dream, we move closer to the heart of that impossible discovery, the moment when light first learned how to shine. In the next chapter, we'll follow Webb's gaze deeper still to the birth of the first stars, and to the question of how something came from nothing. Before there was light, there was silence. The young universe was a sea of darkness, dense, hot, and blinding in its invisibility. For nearly 380,000 years after the Big Bang, matter and radiation were locked together, colliding so frequently that no light could travel freely. Space was bright with energy, but opaque to vision, a glowing fog without form. Then, slowly, everything cooled. Electrons joined protons to form the first neutral atoms, mostly hydrogen and helium. With that union, light was freed. Photons began their long flight through space, stretching and fading over billions of years. That first flash became what we now call the cosmic microwave background, the faint whisper of creation still echoing in every direction. The James Webb doesn't see that afterglow. It looks beyond it, into the next great transformation, when the first stars ignited. It peers into a time astronomers call the cosmic dawn, when gravity began pulling matter together into glowing spheres that would reshape everything. From silence came fire. Those first stars were nothing like our sun. They were titans, hundreds of times more massive, burning hotter and dying faster. Composed almost entirely of hydrogen, they had no metals, no dust, no planets. When they lived, they burned blue-white. When they died, they exploded with a force that scattered the first heavy elements into space: carbon, oxygen, iron, the ingredients of life. Think of it. Every breath you take is laced with the ashes of those first stars. The calcium in your bones, the gold in your rings, the oxygen in your blood, all forged in ancient fire, carried through cosmic winds, recycled by galaxies long gone. Webb doesn't just study the past, it studies the family tree of existence. Through its golden eyes, we can almost see the first sparks forming, gas clouds collapsing under their own weight, friction building, atoms squeezing until fusion begins. From that instant, light became memory. Those early stars lived brief, violent lives, each one a flicker in the vast dark, but together they ended the cosmic night. The darkness didn't vanish all at once. For hundreds of millions of years, light battled with fog. The ultraviolet radiation from those newborn stars began ionizing the hydrogen gas around them, clearing small transparent bubbles through which light could finally escape. It was the universe learning to see itself. This process, called rionization, was like dawn breaking over a frozen landscape. First a shimmer, then a glow, then brilliance. The James Webb captures that transition in exquisite detail, showing how the first galaxies pierced the ancient fog, turning chaos into architecture. Every pixel in Webb's deep field images is a paradox, light so old it seems newborn. When we see it, we're not witnessing the past, we're participating in it. The photons striking Webb's mirrors tonight left their source when the universe was only a few 100 million years old. They have traveled so far that their wavelength stretched 1,000-fold, turning visible light into warmth. To Webb, the early cosmos looks like embers caught in a slow wind, crimson and gold, fading, flickering. Those faint red dots in its images are the first chapters of everything. Even the smallest, dimmest smudge contains enough stars to rival the Milky Way. But unlike us, they existed in a universe still unstable, still learning to hold itself together. What makes this vision almost spiritual is how fragile it is. A single vibration of heat, a single mechanical twitch, could drown out those ancient signals. That's why Webb must remain so cold, so silent, so impossibly patient. Its stillness is what lets it hear the heartbeat of creation. When you think of light, think not just of brightness, but of memory. Light is time's handwriting. It records everything it touches. The glow Webb captures isn't happening now. It happened, and the universe has been carrying it across billions of years, like a message in a bottle adrift on an endless sea. Every new image Webb sends home adds another verse to that story. Astronomers gather around their screens, reading these messages line by line, decoding the grammar of galaxies. Each cluster, each arc of light, tells us how matter sculpted itself into order. The universe was not built in an instant, It bloomed, patient and deliberate, like frost forming patterns on glass. And yet, even this patient beauty hides mystery. Some of the galaxies Webb observes appear too bright, too structured, too soon. The physics we know can't easily explain them. Either our models need rewriting, or there are unseen forces guiding the rhythm of growth. Some whisper that maybe dark matter is different than we thought. Others suspect the early universe was denser, more fertile, more chaotic. But perhaps that's the point. Creation was never meant to be predictable. It was meant to surprise us. To look at Webb's images is to witness astonishment frozen in gold. The cosmos did not evolve by logic alone. It unfolded like a poem, every stanza dictated by energy and chance. The more we learn, the more humbling it becomes. The James Webb Telescope isn't showing us perfection, it's showing us process. The universe is still becoming. Every atom, every galaxy, every life form is part of that ongoing transformation. If you feel small in the face of such vastness, remember, you are made of the same light that Webb captures. Your body hums with atoms forged in forgotten suns. In a sense, you are the universe remembering itself. The first light never truly died. It only changed form. It still flows through you now, in the warmth of your skin, in the breath you exhale, in the thoughts that flicker through your mind. The cosmos didn't end with stars. It continued inside the beings capable of wondering where it began. And as Webb continues to stare into that ancient dawn, we are reminded of something simple and eternal. The universe has always been awake. Even in its darkest moments, it was preparing to shine. When the first deep field images from the James Webb were released, scientists expected to see faint primitive galaxies, cosmic infants barely holding their shape. Instead, they found something astonishing. The early universe was already filled with vast, mature galaxies, spirals, disks, and clusters glowing with billions of stars. By all our current models, these galaxies should not have existed yet. It was as if Webb had opened a history book and found skyscrapers in the Stone Age. Cosmologists stared in disbelief. The first galaxies we believed would take hundreds of millions of years to form were already thriving less than 300 million years after the Big Bang. Something was off, either our understanding of time or of creation itself. At first, researchers thought it might be a trick of the light. Perhaps gravitational lensing, where massive objects bend light, was magnifying distant galaxies, making them appear closer and older than they truly were. But the data persisted, even after careful recalibration. The impossible galaxies were real. These galaxies were surprisingly bright, meaning they contained far more stars than expected. But brightness requires mass, and mass requires time to accumulate. For the universe to create so many stars so early, something fundamental must have accelerated its growth. Some physicists called it cosmic adolescence, a universe growing up too fast. In science, contradictions are sacred. They force us to look again, to rebuild our stories. Webb's discovery cracked open one of the most profound mysteries in modern cosmology. How did structure emerge from chaos so quickly? If galaxies could mature in a fraction of the predicted time, maybe our equations had been too cautious, or maybe time itself flows differently on cosmic scales. One theory suggests that dark matter, the invisible framework of the cosmos, was far denser in the early universe. This extra gravity could have pulled gas and dust together faster, igniting stars sooner. Another idea proposes that early stars were simply more efficient, burning brighter and living shorter, creating generations of galaxies at incredible speed. But beyond equations, there's something quietly poetic in the idea that the universe couldn't wait to shine. It rushed forward, eager to create, like a child impatient to speak its first words. Those impossible galaxies are the universe's earliest attempts at art, messy, radiant, alive. When Webb captures their light, it doesn't just photograph them, it translates them. The telescope sees in infrared, stretching the ancient glow into visible form. What was once heat becomes color. What was once invisible becomes breathtaking. In each image, you can almost sense the tension between youth and eternity. Look closely at the data, and you'll notice that some galaxies are smooth and symmetrical, while others are chaotic and torn, cosmic storms in progress. It's as if the universe was sculpting with trembling hands, experimenting with beauty, learning the balance between gravity and grace. And yet, these images also reveal something more intimate, the fingerprints of time itself. Each warped streak of light, each curved galaxy, bears the mark of cosmic expansion. Space is not still, it stretches. Every moment you're alive and galaxies move farther apart, the light Webb captures is stretched too, not because it travels, but because space itself grows between it and us. This redshift, as scientists call it, is the universe's breathing pattern. Webb reads that breath, converting wavelength into distance, distance into age. It's like listening to the cosmos exhale across eternity. The farther the light has traveled, the deeper into the past we see. And in that past we see ourselves, not in form, but in pattern. Galaxies swirl like the neurons of a sleeping brain. Clusters resemble webs of thought, filaments of connection stretching across infinite distance. The universe, it seems, organizes itself the way life does, not through command, but through harmony. Perhaps that is why the discovery of these impossible galaxies feels personal. It's not just about when the universe began, but how it began, not through perfection, but through urgency, curiosity, and constant evolution. It mirrors the very process of understanding itself. The James Webb Telescope became a mirror for humanity's own mind. We build machines to look deeper, and in their reflections we find our own desire for meaning. These galaxies shouldn't exist, yet they do. Just like us. Scientists continue to debate their nature. Are they truly as massive as they appear? Or are we misinterpreting the light, confusing brightness for bulk, distance for time? Webb's sensors are precise, but the cosmos loves to play with perspective. Each new discovery redefines the next question. And that's the beauty of exploration. The more we know, the stranger reality becomes. Knowledge doesn't close doors, it opens windows to deeper wonder. The universe is not a solved equation, it's a living story, still being written by the stars themselves. To watch Webb's images unfold is to experience a kind of slow-motion enlightenment. You can almost feel the hum of starlight against your skin, like the faint vibration of something too vast to comprehend. It's not about answers, it's about remembering that mystery is sacred. So tonight, as you imagine those golden mirrors floating in the void, think of them not as tools, but as translators of silence. They capture the music of ancient fire and turn it into sight. They remind us that even impossibility has its place in creation, and maybe that's the secret these galaxies whisper, that the universe doesn't follow rules, it invents them. It bends time, twists probability, and still manages to create beauty in the process. The James Webb Telescope didn't just see the impossible, it proved that wonder is the most real thing we have. In the next chapter, we'll drift closer still into the hearts of these galaxies themselves. There, within swirling clouds of gas and gravity, we'll find the engines of existence, the black holes that shape and devour, the unseen architects behind the light. In the heart of nearly every galaxy, including our own, lurks a black hole. But the ones Webb discovered in the early universe defy all reason. They are too massive, too soon, millions, even billions of times heavier than the Sun, already mature when the cosmos itself was still young. According to our theories, They shouldn't exist, and yet they do. Black holes form when massive stars collapse under their own gravity, crushing all matter into a single, infinite point, a singularity. But to reach such colossal sizes in just a few 100 million years after the Big Bang, that breaks every rule of cosmic growth we know. The question echoes through every research lab: how did they grow up so fast? Some scientists propose that these black holes didn't start small at all. Perhaps they were born from direct collapse, vast clouds of gas falling inward before stars could even form, creating seed black holes millions of times more massive than our Sun from the very beginning. Others suggest they grew by consuming matter at impossible speeds, defying the so-called Eddington limit, where radiation should push back against gravity's pull. Webb's instruments are designed to find these hidden giants, not by seeing them directly, for nothing escapes their darkness, but by observing their surroundings. As matter spirals into a black hole, it heats up, glowing brilliantly in X-rays and infrared. These emissions, caught by Webb's sensitive sensors, reveal the fingerprints of creation and destruction intertwined. What's haunting about these observations is their duality. Black holes are destroyers and creators at once. They devour stars, but in doing so, they ignite galaxies. Their gravitational influence sculpts cosmic structure, drawing gas into dense regions where new stars are born. In a strange, poetic symmetry, death becomes the seed of light. Imagine this: a black hole billions of times heavier than the Sun, wrapped in a halo of gas so luminous it outshines entire galaxies. Its edges swirl like paint in slow motion, each orbit an eternity. Space itself bends inward, and time stretches thin. Around this singularity, photons dance in circles, trapped between existence and oblivion. And yet, Webb shows us something more intimate than terror. It shows us elegance. The light that reaches us from these distant monsters has traveled across the ages, distorted but intact, whispering secrets about how gravity sculpts beauty. Through Webb's mirrors, we can almost feel the hum of space-time vibrating, steady and slow, like the breath of the cosmos itself. Some researchers believe these early black holes might hold clues about the nature of dark matter. If dark matter helped gather gas faster, it could have accelerated black hole formation. Others wonder if there are forces we've yet to name, subtle corrections to general relativity that only reveal themselves under extreme conditions. But beneath the math and data lies a deeper wonder, that in the quiet of the early universe, chaos found order. From fire and collapse, symmetry emerged. The same equations that describe black holes also describe the flow of rivers, the pull of tides, the rhythm of a heartbeat. Gravity is not destruction, it is belonging. When we think of black holes, we imagine voids, emptiness, endings. But Webb teaches us that they are also origins. Every galaxy, including ours, owes its shape to one. Their gravity acts like a conductor, guiding the orchestra of stars into harmony. Even now, the Milky Way revolves around its own hidden heart, Sagittarius A, silent and invisible, yet holding everything together. The James Webb Telescope sees further than any human eye could ever dream. When it stares into the glow surrounding these ancient black holes, it sees the early blueprint of balance, the cosmic yin and yang. For every collapse, an expansion; for every end, a beginning. The photons Webb collects left those regions when Earth was not yet dust. They crossed billions of years, dodging collisions, stretched by the universe's expansion until they landed gently on gold mirrors forged by human hands. In that union of light and curiosity lies something sacred, proof that even darkness serves the story of light. If black holes are the punctuation marks of existence, Webb is the translator that reads them aloud. Each discovery turns silence into comprehension, fear into fascination. We once thought black holes were boundaries. Now we see them as bridges, linking the seen and the unseen, the known and the eternal. And perhaps that is the quiet truth of the universe, that nothing is wasted. Every fall gives rise to flight. Every disappearance leaves behind a trace. Every shadow contains the memory of light. The cosmos does not fear its own darkness. It uses it to write contrast into being. Webb's findings remind us that the universe is still learning what it can become. The early black holes, impossibly massive and ancient, are not errors in our equations. They are invitations to think bigger, to see not failure in mystery, but opportunity in awe. When you look at the sky tonight, know that somewhere out there, light is still escaping from the edges of an ancient horizon, carrying stories from before there were words, before there was life. And here you are, made of that same matter, listening to its echo through time. Perhaps black holes shouldn't exist. Perhaps we shouldn't either. But we do. And that improbability is the most cosmic truth of all. As we drift onward, deeper into Webb's discoveries, we leave behind the darkness of singularities and turn towards something even stranger. The invisible threads that connect all things, the four fundamental forces that hold reality together. Everything in the universe, from galaxies spinning light years apart to atoms trembling in your fingertips, is governed by four fundamental forces. They are invisible, indivisible, eternal. Without them, nothing would move, bind, or even exist. The James Webb Space Telescope doesn't merely capture their effects. It reveals their choreography across the grand stage of time. The first is gravity, the quiet architect. It's the reason galaxies swirl and moons remain tethered. Though it's the weakest of the four, it's also the most patient. Gravity never sleeps. It shapes mountains and orbits with the same slow devotion. When Webb peers into ancient light, it sees gravity's fingerprints, the curved arcs of galaxies bending under invisible weight, the subtle dance of matter obeying an unseen conductor. Next comes electromagnetism, the painter of light. Every photon Webb captures is an expression of this force, a conversation between energy and space. It binds atoms into molecules, carries warmth from the sun to your skin, and allows telescopes to translate darkness into color. Electromagnetism is why the universe is visible at all. Without it, creation would be silent and blind. Then there are the strong and weak nuclear forces, keepers of the subatomic realm. The strong force binds quarks into protons and neutrons, the very bricks of matter, while the weak force governs decay, transformation, and rebirth at the smallest scale. Together, they remind us that even stability is built on constant change. Stars exist because of this interplay. Every heartbeat of fusion in their cores is the song of these two forces in harmony. To imagine these forces is to imagine balance itself. Gravity pulls everything together, while electromagnetism pushes outward, creating tension, a cosmic breath, inhalation and exhalation in endless rhythm. The strong and weak forces weave the fabric at the tiniest level, stitching permanence into impermanence. The universe endures because opposites collaborate rather than compete. The James Webb Telescope captures this collaboration in real time. When it photographs the thin filaments of galaxies stretching for millions of light years, it's not just recording structure, it's recording relationship. Each swirl of starlight is gravity in motion. Each glow of infrared a pulse of electromagnetism, each atom a memory of nuclear fire. Scientists often describe the four forces mathematically, but the poetry behind them is undeniable. They are the laws that make harmony possible, the cosmic equivalent of rhythm, tone, melody, and silence in a universal symphony. Even chaos dances to their beat. Imagine standing on a quiet shore, feeling the pull of gravity beneath your feet, the hum of electromagnetic light on your skin, the invisible storm of particles inside your atoms. You are never separate from these forces. You are them, assembled into awareness. Webb's distant observations and your present breath obey the same physics. That unity is what makes science spiritual. Gravity may seem romantic, stars drawn together, galaxies colliding, but it's also lonely. It never lets go. Every mass in the cosmos calls to every other forever. When Webb measures that pull across billions of light years, it reminds us that connection is not a metaphor, it's a fundamental law. Electromagnetism, in contrast, is conversation, the exchange of photons, the shimmer between atoms, the warmth of contact. It is the bridge that turns isolation into communication. Light is electromagnetism made visible. When Webb converts those ancient photons into color, it's decoding the oldest dialogue in existence. The strong and weak forces live where sight cannot reach. They are the hidden artisans crafting stability from chaos. The strong binds fiercely, never letting go. The weak allows decay, ensuring that nothing stagnates. Together, they echo the balance of life and death, of birth and dissolution. Every star Webb observes is a nuclear cathedral where these forces sing creation into being. To scientists, unifying these four forces into a single equation, a theory of everything, remains the ultimate dream. But maybe unity isn't found in formulae. Maybe it's already present in the simple truth that all things influence all others. The universe does not need to be solved to be whole. Webb's golden mirrors, aligned to nanometers, depend on those same forces to function. Gravity holds its orbit. Electromagnetism powers its sensors. The strong and weak forces hum inside every atom of its structure. The machine that explores the cosmos is itself a microcosm of the cosmos. And this symmetry leads to a humbling thought. The universe is self-aware, not in consciousness but in reflection. Through us, it studies itself. Through Webb, it watches its own birth unfold. Through these four forces, it maintains continuity between what was and what will be. Every time a photon strikes Webb's detector, it carries the combined story of these forces, gravity stretching its path, electromagnetism granting it life, nuclear fusion birthing it in a star's core. Each speck of light is a compressed biography of existence. The beauty of science lies not in certainty, but in intimacy. To understand these forces is to touch the pulse of reality. They are not distant abstractions. They're the silent scaffolding holding your heartbeat, your memories, your capacity to wonder. As we drift deeper into Webb's discoveries, one truth grows clear. The same four forces that shape the galaxies also shape the soul that longs to understand them. The cosmos is not indifferent, it's consistent. Its patterns repeat at every scale, in starlight, in atoms, in thought. Perhaps this is why the universe feels familiar when you stare into it. Every force that binds a galaxy binds you too. Every attraction, every vibration, every balance of power is mirrored within. You are gravity, you are light, you are decay and renewal. The four forces are not distant gods, they are the architecture of your being. And as Webb continues its patient gaze, recording the symphony of physics played in the silence of space, we realize something profound. The universe does not merely exist, it holds itself together, not by accident, but by design so elegant it borders on art. These are the four forces of forever: gravity's embrace, electromagnetism's voice, the strong force's loyalty, the weak force's release. They are the grammar of everything, the pulse beneath creation, the whisper that says all is connected. Every story has a heartbeat, even the universe's. For billions of years, creation has expanded, stretched and cooled, moving from unimaginable heat to the calm we now inhabit. The James Webb Space Telescope watches this cooling not as decline, but as transformation, the universe trading fire for form, chaos for complexity. In the beginning, everything burned. The early cosmos was a furnace of particles colliding, merging and bursting apart. But as space expanded, heat dispersed, atoms slowed, stars stabilized, and galaxies formed. With every passing epoch, temperature gave way to structure. The universe was learning to breathe. Webb's infrared eyes can still sense this cooling. It detects the soft glow of galaxies at different distances, each a different chapter in time, each cooler than the one before. The light stretching into red, the wavelengths lengthening like an exhale. This redshift isn't just a measure of speed, it's the universe's sigh, the cooling of its once furious pulse. Even now, the cosmic microwave background hums at a temperature just above absolute zero, 2.7 Kelvin. That faint radiation, detected everywhere, is the aftertaste of the Big Bang. It's the universe's oldest memory, the final whisper of its fiery birth. When Webb measures faint glows in deep space, it listens to that same lullaby of cooling light. But cooling is not the same as dying. It is refinement. In cooling, stars stabilize. In cooling, planets solidify. In cooling, water condenses, life begins. Heat once ruled everything, but balance was born only when the cosmos learned to let go. The same physics that extinguishes fire also nurtures equilibrium. Think of a blacksmith's forge. At first, the metal is molten and wild, untouchable. As it cools, it becomes strong, capable of holding shape, of becoming something useful. The universe followed that same arc, cooling into creation, solidifying into harmony. Webb captures this serenity. Its instruments read the infrared glow of dust clouds, remnants of stellar death, drifting like ash across eternity. Within that dust, new stars gestate. Cooling births potential. Every dying ember becomes a cradle. The telescope doesn't witness endings. It witnesses exchanges of heat for meaning. When you look at Webb's deepest images, what you're really seeing is temperature written as color. The reds and oranges signify light stretched thin by time and distance, once blue hot, now ancient and cool. In those shades, we see the universe growing old gracefully. There is something deeply human in this cooling. We too burn brightly in youth and settle into warmth with time. Our passions change frequency, stretching from blue to red, from intensity to endurance. The same thermodynamics that govern galaxies also govern the heart. Some scientists predict a distant future when all stars will burn out, when the universe will be dark, cold, and silent. They call it the heat death, a phrase both accurate and misleading, because death, in cosmic terms, is never the end, it's transformation. Energy never disappears. It only changes form, moving from visible to invisible, from heat to memory. Even then, even in that hypothetical cold, motion will persist. Atoms will still vibrate, black holes will still whisper, and gravity will still connect what remains. The universe, in truth, does not know stillness. It only knows slower rhythms. Webb, gazing across time, captures this gradual decrescendo, the softening of light, the stretching of space, the slowing of flame. It's not a tragedy, it's a symphony finding its final notes. Every sunset we watch is a rehearsal for that universal diminuendo. And yet, there's beauty in decline. Cooling is what allows contrast. Stars glowing against darkness, warmth existing because of cold. The universe's fading temperature is what gives rise to definition, shape, perspective. Without cold, we wouldn't know light at all. Webb's detectors must be kept colder than deep space itself. a paradoxical mirror of the cosmos it studies. Only by matching the universe's chill can it perceive its faintest heat. Its sensors rest at 233 degrees C, suspended in silence, waiting for whispers of warmth older than time. Through its stillness, Webb becomes the universe's confidant. It listens to photons that have traveled for billions of years, stretched thin but unbroken. In each faint glimmer lies evidence of persistence, of how something can cool for eternity and still glow. Perhaps that's the quiet lesson of cosmic cooling. Endurance doesn't require fire, only balance. The stars burn because they release, not because they cling. When they run out of fuel, they don't vanish in shame. They return their light to the universe, leaving space for others to shine. The same law applies to us. We are temporary furnaces of awareness, each exhaling energy back into the whole. Our eventual cooling isn't failure, it's completion. Like stars, we give our heat to the next generation of light. When Webb looks at ancient galaxies dimming at the edge of visibility, it's not witnessing extinction, it's witnessing continuity. Light fades only because it travels so far. Time is not a thief, but a messenger, carrying warmth into tomorrow. In the grand equation, cooling is compassion. It's the universe making room. If everything remained hot and dense, nothing could form, no story could unfold. Expansion and cooling are the cosmos's way of saying, there is space for you here. And so the James Webb Telescope continues to drift in its cold vigil, mirroring the very process it observes. Its silence is not emptiness, but clarity, a perfect harmony between observation and being. In the chill of space, creation never stops. It simply slows, refines, listens, and in that stillness, beauty becomes infinite. The more Webb looks into deep space, the more it reveals something hauntingly beautiful. Most of the universe cannot be seen. The galaxies and stars we marvel at are just the frosting, a thin, luminous layer floating atop an invisible ocean. Beneath it lies dark matter, an unseen lattice holding everything together. This cosmic skeleton doesn't glow, reflect, or emit light. We can't detect it directly, yet its presence is undeniable. Galaxies spin too fast to be held together by visible matter alone. Clusters of galaxies bend light in ways only hidden mass can explain. Dark matter is the silent scaffolding of existence, the threads upon which reality hangs. Webb, with its deep infrared gaze, doesn't see dark matter itself but maps its influence. The shapes of galaxies, their clustering, their slow migrations through space, all betray the touch of this invisible hand. Like wind shaping sand dunes, dark matter sculpts creation without ever revealing its face. Scientists estimate that roughly 85% of all matter in the universe is dark. Everything we can see, planets, stars, humans, atoms, amounts to less than 15%. The rest hums quietly in shadow, holding galaxies in their cosmic choreography. We are, in truth, creatures of the minority, luminous anomalies suspended in darkness. But this darkness is not emptiness. It's structure, discipline, guidance. It's the web that catches light. Imagine vast filaments stretching across the universe, each hundreds of millions of light years long, made not of atoms, but of gravity itself. Where these filaments cross, galaxies form like dew gathering at the joints of a spider's web. Webb's data allows cosmologists to trace these filaments indirectly by observing how light bends as it passes through them, a phenomenon called gravitational lensing. Each distortion, each curve of starlight, is a signature of mass unseen. The telescope doesn't just photograph the universe, it reads its fingerprints. The term dark matter might sound sinister, but perhaps it's simply misunderstood. It's not darkness in the moral sense. It's the quiet companion of light. If light is revelation, Dark matter is restraint. Together they create balance. The universe shines not despite the dark, but because of it. This balance echoes in everything we know. Musicians rely on silence as much as sound. Artists use shadow to define shape. Even your own thoughts require quiet to form meaning. The cosmos follows that same principle, harmony through contrast. Some physicists suspect dark matter may consist of exotic particles that barely interact with ordinary atoms, WIMPs, axions, or yet unnamed entities. Others propose more radical ideas, that gravity itself behaves differently at cosmic scales. Each theory is a fragment of the same truth, that the universe is deeper than our senses can perceive, and that realization is strangely comforting. To know that most of existence is invisible is to remember that mystery is not the absence of knowledge, but the space that gives it depth. Webb's golden mirrors don't conquer that mystery, they honor it, transforming the unseen into something felt. When you gaze at an image from Webb, every galaxy you see rests on invisible foundations. You're looking at architecture built by absence, light arranged by gravity you cannot detect. The stars are lanterns hung along invisible strings, each one humming in the dark. The cosmic web isn't static, it breathes. Over billions of years, dark matter pulls galaxies closer along its filaments, while cosmic expansion stretches them apart. This tension between connection and distance defines the universe's shape. Even separation, it turns out, is a form of belonging. And somewhere within this infinite tension, we exist, small observers on a fragile world, peering outward, trying to chart the contours of what we cannot see. The irony is profound. Creatures made of light studying the nature of shadow. Webb's discoveries are a testament to patience. To map the invisible, we must listen, not look. The telescope waits for faint distortions, slight reddenings, whispers of alignment, subtle clues that speak louder than brilliance. Science, like starlight, rewards silence. Some philosophers see in dark matter a metaphor for consciousness itself, the unseen structure holding our thoughts, emotions, and dreams in place. Just as galaxies rely on hidden mass, meaning relies on invisible gravity. What connects our memories, our identities, our love, might not be measurable, but it's no less real. And perhaps that's why these findings resonate so deeply. They remind us that what truly binds the universe is not light but connection. Gravity, time, and unseen substance weave a web not of isolation but of interdependence. Even the voids between galaxies are part of the design. Every new observation Webb sends back is a portrait of that unity. Galaxies appear not as scattered dots, but as pearls strung along invisible threads. The universe is not chaos, but choreography. Slow, deliberate, breathtakingly precise. If dark matter is the body of this web, then dark energy, its mysterious counterpart, is the breath that expands it. While one binds, the other pushes apart, together creating the cosmic rhythm of inhale and exhale. Webb studies both, mapping not just where things are, but how they move. And in that motion lies poetry. The universe expands, not to escape itself, but to grow into its potential. Just as a mind expands through curiosity, so too does space through energy. The void is not empty, its expectation made visible. In its quiet orbit, Webb floats among these contradictions, translating them into harmony. It shows us that what we cannot see defines what we can. The invisible is not our enemy, it is our foundation. Maybe the most profound truth of all is this: the universe is held together by what it hides. And that hidden web, vast, silent, immeasurable, hums softly in every heartbeat, every photon, every thought that dares to wonder why. If dark matter is the skeleton of the universe, then dark energy is its breath. It's the unseen force pushing everything apart, accelerating expansion against gravity's pull. The James Webb Space Telescope doesn't measure dark energy directly, but every image it captures, every stretched galaxy, every elongated wavelength carries its signature. The cosmos is not static, it's inhaling. Astronomers once thought gravity would slow this expansion, perhaps even reverse it one day. But when scientists observed distant supernovae in the late 1990s, they found the opposite. Galaxies weren't decelerating, they were accelerating. Something, somewhere, was adding energy to empty space itself. They called it dark energy, though dark only means unknown. Imagine exhaling into an infinite balloon. With every breath, the balloon expands faster, not slower. The galaxies are dots, painted on its surface, moving away from each other not because they're traveling through space, but because space itself stretches between them. The farther apart they are, the faster they separate. Webb sees this in the reddening of light. Ancient photons pulled like silk threads across growing distance. The universe, it seems, is breathing deeper with time. Every second, every heartbeat, the cosmic fabric grows, and yet, paradoxically, we don't feel it. Gravity binds our small corner tightly enough to resist expansion. The galaxies drift apart, but your atoms remain loyal. It's a quiet duality. Cosmic expansion on one scale, stability on another. Webb's role is like that of a patient listener, attuned to the faint rhythm of this breath. It measures how galaxies cluster, how light bends, how distances stretch. Each observation becomes a note in a melody that describes the universe's tempo, a song of acceleration sung in silence. Dark energy makes up roughly 70% of everything. It doesn't push galaxies like wind against sails. It stretches the fabric itself. Space creates more of itself every moment. There is no center, no edge, only expansion everywhere all at once. When Webb peers billions of light years away, it's not seeing distance, it's seeing time itself unwind. This discovery rewrote our understanding of fate. The universe will not collapse back into a singularity. Instead, it will drift, expanding ever faster, cooling, dimming, until galaxies slip beyond one another's sight. Someday the night sky will fade to darkness, not because stars die, but because light can no longer bridge the growing void. But to call that tragic is to misunderstand the rhythm of things. Expansion is not loss, it's generosity. Space grows because energy demands room to unfold. The universe's breath is an act of grace, a gentle surrender to infinite potential. Some physicists describe dark energy as a property of the vacuum itself, a kind of quantum pressure born from the restless vibration of nothingness. Even emptiness hums. Even silence has a song. Webb's detectors, tuned to the faintest wavelengths, are listening for that hum in the way light behaves across vast distances. Others suspect dark energy might not be constant, that it could weaken or strengthen with time. If it grows stronger, galaxies could drift apart so violently that even atoms will be torn asunder, in a final event called the Big Rip. If it fades, expansion may slow again, restoring balance. The truth, like all great mysteries, remains in motion. For now, Webb provides the most detailed chronicle of this expansion ever recorded. Its deep field images are snapshots of the universe breathing through epochs, from rapid youth to graceful maturity. Each frame is a portrait of motion so immense it defies comprehension, yet so delicate it feels almost human. Consider how breath defines life. To inhale is to receive, to exhale is to release. The cosmos follows that same ritual. Expansion and gravity, dark energy and dark matter, inhale and exhale, endlessly intertwined. Even at the grandest scale, the rhythm of being persists. And perhaps, hidden within this cosmic respiration, lies the simplest truth. Existence thrives in balance. The universe expands not to escape itself, but to make space for creation. Each new patch of stretched fabric becomes the stage for future stars, future stories. The void is not emptiness, it's anticipation. Webb's golden mirrors are reflections of that same principle. Perfectly curved, delicately balanced, they rely on the tension between precision and flexibility to function. They expand and contract ever so slightly as temperatures shift, breathing with the universe they observe. It's humbling to think that something as immense as dark energy and something as fragile as a telescope's mirror share the same language of expansion and balance. Both teach us that stillness isn't the absence of motion, it's motion in harmony. As we continue to map this unseen force, we're reminded that discovery doesn't end mystery, it deepens it. The more Webb reveals about dark energy, the more we realize how much we don't know. And yet, that uncertainty is what keeps us alive, intellectually, spiritually, cosmically. When you take a slow breath tonight, know that you're participating in the same rhythm that governs galaxies. Every inhale mirrors expansion, every exhale, contraction. You are not separate from the universe's breath, you are part of it. Perhaps that's what Webb's images truly show us, not just ancient galaxies or glowing nebulae, but the physical evidence of a living universe, one that grows, breathes, and evolves, carrying us within it like a quiet thought. The universe will continue to expand long after we're gone, its breath eternal, its rhythm undisturbed. But in this brief moment, we are here to witness it, to marvel at the impossible harmony between everything seen and unseen. And as Webb drifts through the darkness, listening to the cosmos breathe, it whispers the oldest truth there is. Existence is not still. It is the act of becoming, over and over again. The most unsettling question of all isn't how the universe works, but why it exists at all. Why is there something rather than nothing? When the James Webb Space Telescope gazes into the oldest light, it's not just collecting data. It's staring directly into that question. Its golden eyes reflect the silence before creation, when even time had not yet learned to move. Before the first atoms, before the first flash, there was nothing, or so we think. But physicists tell us that nothing is never truly empty. Even the vacuum teems with virtual particles, flickering in and out of existence. Space itself hums with potential. The universe, it seems, didn't emerge from a void. It emerged from possibility. Webb's images of the earliest galaxies are, in a sense, photographs of the universe remembering how to exist. They show us that even in the apparent emptiness, structure was waiting. Laws, constants, and relationships poised like notes on a score, ready for the first vibration of creation. But what is nothing? The absence of matter, the absence of energy, or something deeper, the absence of distinction itself. If there was no space, no time, no before or after, how could the universe begin? Some cosmologists suggest that beginning is a misleading word. The universe didn't start, it transitioned, from potential to manifestation, from silence to sound. It's difficult to picture because our minds are bound by time. We think in causes and effects, yet the Big Bang may have been neither. It may have been the natural fluctuation of quantum fields, an inevitable bloom of existence from its own uncertainty. Nothingness, unstable by nature, might have been compelled to become something. To Webb, this theory isn't abstract. Each pixel of its deep field images holds the echo of that first instability. Faint radiation, stretched and cooled, still whispering the story of transformation. The telescope sees the residue of creation written in ancient light. It doesn't answer why the universe exists, but it shows that existence was not an accident. It was a tendency. Perhaps the universe came into being not because it was possible, but because possibility itself demanded expression. Just as silence invites sound, emptiness invites form. The void wasn't a failure of being, it was its seed. When you stare at the night sky, what you're really seeing is the echo of that decision, the universe choosing to exist. Every galaxy is a declaration, I am. The James Webb Telescope, in turn, is our way of answering back. We see you. Some philosophers find comfort in this symmetry. The cosmos woke itself into awareness through us. Matter became mind, and mind became mirror. When Webb looks outward, the universe is, in a sense, observing itself, contemplating the meaning of its own emergence. Even the concept of nothing might be flawed. In quantum theory, the vacuum isn't an empty void but a restless field, buzzing with energy fluctuations. What we call nothing might be the densest mystery of all, a cauldron of invisible ingredients capable of birthing space, time, and everything that would follow. Einstein's equations suggest that space-time can curve, warp, and stretch, but they never forbid it from beginning. The Big Bang was not an explosion in space, it was the expansion of space. Everything everywhere, expanding from everywhere else. There was no center, only emergence. Webb's infrared sensors capture the faint light from the epoch when hydrogen first gathered into stars, when nothingness began to shine. Those early fires are the proof that emptiness was pregnant with energy. Darkness, it turns out, is fertile, and that fertility extends to us. The atoms in your body were forged in stars that formed from clouds born of the Big Bang's residue, the ashes of the first moment. You are not made in the universe, you are made of it. The question of why the universe exists is also the question of why you do. Maybe there is no ultimate why. Maybe existence is the simplest state, the ground note beneath everything. To ask why there is something rather than nothing might be like asking why a melody chooses to begin. Because silence was waiting to be broken, because potential longed to move. The universe doesn't need permission to be, it simply is. And Webb, floating in its silent vigil, doesn't demand answers. It listens, it receives, it transforms photons into understanding, noise into narrative. Through its calm patience, it reminds us that not every mystery must be solved. Some are meant to be witnessed. In the deepest sense, nothing and something are partners. Without nothing, there would be no room for being. Without being, nothing would never know itself. They coexist like inhale and exhale, presence and absence, light and shadow. Perhaps that's the quiet truth the James Webb Telescope whispers to us from its frozen post beyond the moon. The universe was never created out of nothing. It was created with it. The void didn't vanish when light arrived. It became the canvas. So when you look at the sky tonight and feel small, remember that smallness is sacred. It means you're participating in the same paradox that gave rise to everything. You are both the silence and the sound, the nothing and the everything, folded into one. And in that awareness, that quiet equilibrium between awe and acceptance, the question of why dissolves. All that remains is gratitude for the fact that anything exists at all. When the James Webb Telescope looks deep into the past, it also looks toward our future. Every image it sends back, each distant galaxy, each faint red arc of light, is both a memory and a prophecy. What becomes of a universe that never stops expanding? How does something infinite learn to end? Scientists describe several possible destinies. The first is the Big Freeze. In this scenario, dark energy keeps stretching space faster and faster until galaxies drift apart beyond sight. Stars burn out, and black holes evaporate. What remains is silence, not destruction, but exhaustion. A universe growing colder, dimmer, gentler, until only the echo of its birth remains. It sounds tragic, but perhaps it isn't. Cooling doesn't mean death, it means rest. The cosmos, after a lifetime of creation, might finally sleep. Webb's images of distant, fading galaxies are previews of that eventual calm, the stars dimming like campfires at the end of a long night. Another possibility is the Big Crunch, the mirror image of expansion. If dark energy weakens, gravity could reclaim dominance, pulling everything back inward. Galaxies would collide, stars would ignite in one final blaze, and the universe would collapse into itself. A second singularity. But that collapse might not be an ending either. It could be a rebirth. A new universe could burst from the ashes of the old. Between those extremes lies a more subtle fate, the Big Bounce, an eternal cycle of expansion and contraction. In this vision, the cosmos breathes forever, exhaling and inhaling, creating and renewing in endless rhythm. Each universe carries the memory of the last, encoded in constants that never change. Webb's golden mirrors, if they could survive, would witness the heartbeat of infinity. But perhaps the most haunting theory is the Big Rip. If dark energy grows stronger over time, even atoms won't survive its pull. Galaxies, stars, planets, all torn apart by relentless expansion. Space itself would unravel, leaving only scattered radiation. It would be, paradoxically, the most peaceful disintegration imaginable, not an explosion, but a soft unbinding. For now, Webb helps us measure which destiny seems most likely. Its observations of distant supernovae and galaxy clusters help refine the strength of dark energy, narrowing the possibilities. So far, the data suggests a universe destined for the Big Freeze. Slow, serene, eternal. That's the poetic truth of science. Every answer ends in humility. The more precisely we measure, the more mysterious the universe becomes. Even the end cannot be pinned down. It shimmers like a mirage on the horizon of time. And yet, Webb's mission is not about endings. It's about continuity. Each photon it catches proves that light outlives its source. Stars die, galaxies fade, but their light persists, traveling endlessly through space, carrying their existence forward. The fate of everything, perhaps, is not disappearance, but diffusion. Maybe that's what eternity really means, not permanence, but persistence. The atoms in your body will one day scatter into the same vast dark, but scattered is not lost. You will return to the cycle, to the dust, to the light, to the quiet pulse of expansion. The James Webb Telescope, drifting through cold silence, embodies that persistence. It too will one day go dark, its instruments frozen, its panels folded. But even then it will remain, a monument to curiosity, orbiting a star that once wondered about itself. If the universe's fate is peace, then every moment of awareness we have is rebellion, a spark against inevitability. Webb's mission is a hymn to that spark, to look, to ask, to feel awe even as the light fades. Imagine the far future, trillions of years from now, when all galaxies are invisible, when the sky is empty. Somewhere, perhaps, new observers will emerge, not of flesh but of quantum dust, curious once more. They will search for light, and perhaps they will find echoes of Webb's discoveries, a record of how the universe once remembered itself. In that distant silence, maybe the cosmos will whisper the same truth it always has, that nothing truly ends. Every photon, every thought, every breath joins the continuum. The universe may cool, but wonder does not. And so, as Webb continues to watch, It teaches us the simplest lesson of all. Endings are only forms of becoming. What we call the fate of everything may just be another beginning waiting to unfold. Light never truly dies. It fades, it stretches, but it endures. Even the faintest glow Webb detects has traveled across billions of years, surviving collisions, absorption, and cosmic storms. Each photon is a traveler, a survivor of creation's first dawn. When we say Webb sees back in time, what we really mean is that light carries memory. Every wavelength is a diary entry written in motion. Stars may perish, but their light keeps their existence alive. In a sense, the universe is a library built entirely of glow. Webb's mirrors act as librarians, collecting these fragments of eternity. Its sensors don't just measure brightness, they translate experience. The deep red hues in its images are time made visible, the fingerprints of persistence across unimaginable distances. To think that light from galaxies billions of years old now rests on the surface of gold mirrors built by human hands, that is poetry made physical. The most ancient stories ever told are being read by a creature that evolved on a small blue planet orbiting an ordinary star, but not all light is visible. Some lingers as warmth, some as radiation, some as echoes in fields we cannot sense. Webb, attuned to the infrared, listens to the tones beyond human perception, the afterglow of existence itself. Its vision stretches where our eyes cannot, revealing that even the invisible still sings. When that light reaches Earth, it is absorbed by minds hungry for meaning. Every discovery Webb makes becomes a mirror for humanity's need to remember. We study ancient stars not to escape the present, but to understand the continuity between their glow and our breath. Each photograph is a reunion. The light Webb captures left its source before the Milky Way even existed, yet it arrives precisely here, precisely now, completing its purpose. It reminds us that time, for all its vastness, is intimate. The universe is patient with its messages. Even as it stretches, light never loses itself. It slows, it reddens, but its essence remains. The same photon that warmed a primordial gas cloud now touches a telescope, a communion across epochs. In the quietest sense, light is faith, not belief, but endurance. It trusts that somewhere, someday, it will be seen. Perhaps that is why we're drawn to it, why candles calm us, why dawn feels sacred. We are the fulfillment of light's patience. Webb's mission will one day end, but its images will not. Stored in archives, replicated across servers, engraved in data crystals, they will travel forward just as photons did, carrying memory beyond their makers. Even information becomes its own form of light. To scientists, these records are data. To poets, they are scripture. Each pixel an affirmation that the universe keeps its promises. What is born of energy cannot truly vanish, only change. When you close your eyes and imagine starlight, you are participating in that immortality. The same physics that lets galaxies shine, lets neurons fire. Thought itself is light, slowed and refracted through biology. Consciousness is a constellation made of matter remembering how to glow. If the universe is fated to fade, then light is its refusal to do so quietly. Even in the big freeze, photons will drift through endless cold, carrying the memory of warmth long after warmth itself is gone. Maybe that is what eternity means, not endless life, but endless remembrance. A record so complete it transcends the need for witness. The light doesn't need us to see it. It shines because shining is what it is. And yet, how beautiful that we are here, that for a moment, awareness exists to admire awareness itself. Webb's mirrors don't just capture light, they complete its journey, they give it purpose. If galaxies are the words of creation, then Webb is the reader. And through its golden gaze, humanity learns that to observe is also to honor, to treat every photon as sacred testimony from the edge of time. So as we continue toward the final part of our journey, remember this: light outlives everything, including the fear of its own fading. Every glimmer Webb records is a reminder that the universe's final truth may not be darkness, but endurance. The James Webb Telescope is more than a machine. It's a mirror held up to existence itself. Its golden panels don't just reflect light. They reflect us, the questioners, the dreamers, the fragile consciousness daring to understand the infinite. Every time Webb opens its aperture, it's as if the universe is looking back. Those distant galaxies, those impossible lights, are not foreign. They are familiar, echoes of the same atoms that form our bones and thoughts. The boundary between observer and observed dissolves in quiet revelation. We built Webb to search for the origin of everything. But what it truly reveals is our origin within everything. Each image, each discovery, is a reminder that curiosity is not separate from creation. It is creation, aware of itself. The telescope orbits far beyond the moon, alone and frozen, yet it embodies the warmth of human hope. Every adjustment of its mirrors, every calibration of its sensors, is a whisper of collaboration among thousands who believed knowledge itself was worth the effort. In its solitude, Webb carries our collective longing. It's the physical manifestation of a species that refuses to stop wondering, even when faced with infinity. It's a monument not of stone or metal, but of faith in perception. When its first image was released, humanity paused. For a moment, the world collectively exhaled. Borders and languages disappeared, replaced by a shared astonishment. The photograph wasn't just data, it was communion. We were reminded that our differences are microscopic compared to the vastness that made us. Through Webb, we rediscovered humility. The telescope doesn't flatter us, it dissolves us into perspective, and yet, paradoxically, it dignifies us too. Because even in the face of eternity, we choose to look. We choose to care. Every galaxy it observes becomes a metaphor for awareness. Countless minds, countless possibilities, all contained within one expanding consciousness. Webb is proof that intelligence is the universe attempting to understand its own beauty. Science and spirituality converge here, not in doctrine but in wonder. The telescope doesn't preach, it listens. It teaches patience, empathy, precision. It shows that truth is not loud, it is quiet, golden, and waiting to be noticed. The more we learn, the more we realize that mystery is not diminishing, it's multiplying. Webb's discoveries don't close doors, they open hallways into deeper questions. And perhaps that's what enlightenment really means. Not certainty, but endless curiosity wrapped in peace. Imagine standing in a dark room and holding up a small mirror. In it, you see not just your reflection, but the faint glow of stars overhead. That's Webb's essence, a mirror large enough to hold both the observer and the observed. In a very real sense, it is an extension of our senses, a new set of eyes for our collective mind. It shows us that the universe is not out there. It is here within awareness, folded into every act of seeing. And maybe that's the most profound discovery of all. We don't live in the universe. We are the universe, briefly conscious of itself. Webb simply gives that realization a stage. Each golden mirror carries the fingerprints of engineers, scientists, dreamers, a mosaic of human intention. Those fingerprints are now reflecting starlight older than time, merging the handiwork of minds with the handiwork of nature. Creation and creator, at last, in dialogue. Even as Webb drifts silently in space, it binds us together on Earth. Every update, every image release becomes a shared ritual, a reminder that wonder is a universal language. In its reflection, we see what's best in ourselves: patience, curiosity, reverence. The telescope will not last forever. But the impulse that built it, the desire to see, to understand, to feel small and yet significant, that will outlive every star, because that impulse is the universe, learning to admire its own light. So as Webb continues to send its messages home, we listen not as masters of knowledge, but as apprentices of awe. We don't need to conquer the stars. We need only to notice them. In that noticing lies peace. In reflection lies meaning. And in every act of looking, the universe becomes a little more aware of its own existence. At the end of this long journey, through galaxies, dark matter, light and time, one truth emerges, soft but undeniable. The universe remembers. Every particle, every photon, every vibration carries the memory of everything that came before. The James Webb Space Telescope, patient and golden, is not simply observing the past, it is awakening memory from the depths of silence. In every image, the cosmos whispers, "I am still here." Think about what that means. The light Webb captures tonight began its journey before the Earth had oceans, before stars like the Sun even existed. It traveled through collapsing galaxies, drifting dust, and billions of years of expansion, only to arrive now to be caught by a mirror the size of a human dream. In that act of catching, of noticing, of interpreting, we have become co-authors of the universe's story. Creation did not end with the Big Bang. It continues every time a curious mind dares to look upward. And perhaps that is the quiet revelation of science. It does not seek to replace wonder, but to perfect it. The more Webb reveals, the swirling galaxies, the phantom webs of dark matter, the ghosts of early stars, the more we realize that reality is not mechanical, but musical. The universe doesn't simply exist, it performs. Every law, every force, every photon dances in rhythm, forming an orchestra so vast that even silence has meaning. We are part of that performance, listeners, notes, and instruments all at once. The telescope's discoveries are not just data points. They are verses in a cosmic poem still being written. Its images are visual prayers, testaments to patience, to precision, to humanity's refusal to accept ignorance as comfort. Each pixel carries light older than language, yet perfectly fluent in emotion. To look at Webb's deep field image is to feel time stretch and soften, to sense that distance itself can be tender. There is a moment, quiet and rare, that every scientist, artist, and wanderer feels when gazing at those images. It is the moment of surrender, the realization that all our calculations, theories, and instruments are, at their core, expressions of longing. We build telescopes not to conquer the sky, but to feel connected to it. We seek the beginning of time because we cannot bear the thought that awareness ends with us. Webb's mirror reflects not only galaxies, but the human need for belonging on a universal scale. And what does it find? That belonging was never lost. The same hydrogen that fuels distant stars fuels our blood. The same carbon forged in ancient supernovae forms our bones. The same laws that govern cosmic expansion shape our growth, our love, our decay. We are not witnesses to the universe. We are its continuation, its brief self-awareness expressed through fragile forms of flesh and thought. Webb's discovery is not just scientific, it is spiritual without needing to say so. When the telescope eventually goes dark, when its mirrors cool, its instruments freeze, and its transmissions fall silent, the light it captured will continue to travel. Long after humanity is gone, those photons will drift through space, carrying the memory of our curiosity. Somewhere, perhaps billions of years from now, Another consciousness might find them and know that once, here, the universe looked back at itself with wonder. In that sense, Webb's mission is already eternal. Its lifespan is not measured in years, but in influence, in how it changes the way we see ourselves. We once thought we were observers of the cosmos, but now we know we are participants in its unfolding. Every discovery expands not just our knowledge, but our empathy. To see the immensity of creation is to understand the preciousness of every small life within it. The telescope teaches us patience, that truth reveals itself slowly, often in whispers. It teaches humility, that knowledge is never complete, and that every answer is a doorway to a deeper question. And it teaches gratitude, that to exist, to think, to wonder, is already a privilege beyond measure. The universe does not owe us meaning. We create it by choosing to look. Imagine, for a moment, that you are drifting beside Webb. There is no up or down, no noise, only the quiet pulse of your own breath and the faint hum of machinery. Before you, the blackness of space stretches infinitely, yet it is not empty. It is full of time, memory, and invisible connections. You realize that the universe doesn't need you to understand it, yet it allows you to try. It invites you, gently, to participate in its stillness. What the James Webb Telescope shows us, ultimately, is that existence is not a question waiting for an answer. It is an experience waiting for awareness. The more we look, the more we feel. The more we feel, the more we belong. In that belonging, the distinction between observer and observed dissolves. The light Webb captures is the same light that lives behind your eyes when you dream. So when you close your eyes tonight, remember that you are part of the same story Webb is telling. You are made of the same starlight it studies, bound by the same forces it measures, drifting through the same expansion it maps. You are not separate from the universe's unfolding. You are one of its verbs. You are how the cosmos learns to speak. If this quiet journey brought you even a moment of peace, I am deeply grateful you spent it here with me. Please, tell me in the comments where you are tonight and what time it is, so that across the world, our small lights can connect into one great constellation of listeners, scattered yet united under the same infinite sky. Your words, your presence, even your silence, they're like little stars guiding me forward. Thank you for drifting through time and wonder tonight. Sleep gently, traveler. The universe is still singing, and you are part of its song.